numbers in the brackets. So all these brackets will eventually be blank when you start with it. And then you start with 0. And then you look at the arrows that's pointing to this bracket. So pointing to this bracket is H that has 10 in the parentheses. So 0 plus 10 equals 10. So you do brackets plus parentheses to get your number in the brackets. Now it's 10. Now pointing to H is G that has 11. So brackets 10 plus parentheses 11 is 21. And now pointing, and then again, we can go from N to D and then N to E. So you have to make sure you get all the arrows like in one time pointing from like one area. I don't know how to explain it. So you can't just like skip. You have to like do all these ones first.
You just have to follow the arrows like it's a path.
Yeah.
So if you have multiple arrows, like let's pretend B also went to E as the prerequisite. You would use E for both of these totals, but if B went from E and D, you would take the higher bracket number and put it and use it with B's parentheses number.
Yes. So there's no example of that on here. Okay, so like if we did F right here, so it'd be brackets plus their parentheses, so 21 plus 5 equals 26. Here it'd be 0 plus 6 equals 6, and then 0 plus 7 equals 7. And then doing A, we would do 7 plus 8 equals 15. B, it's pointing to D, so 6 plus 7 is 13. And then F, if we did this, it was like 21 plus 5 equals 26. C is 26 plus 2 is 28. And then same thing with B and A, so we got 13 and 15. And then the start one, so since it has multiple arrows going from it, you pick the highest one. So 28 is higher than 13 and 15, so 28 gets to be in these brackets. And then now you have your priority to start your actual path.
So here we have two processors, and we go to start, and since A, B, and C have no prerequisites, all of them would have one line underneath it saying that they're open and ready to be assigned. So we assign C, we assign C to processor 1 because it has the highest priority. With critical path algorithm, we're assigning priority based off the brackets.
So now we're going to
C
have
is 2 hours, then we go to the lowest number, which would be 0 at processor 2, and assign A to it because A has the bracket number of 15, and that task gets assigned. And while processor 2 is working on task A, processor 1 finishes up task C, and because C finishes up, F opens up as a task that can be assigned, and we still have B, but between the two of them, F has a higher priority, so we assign F next, which takes 2 plus 5, and we use the parentheses number in the scheduling. 2 plus 5 is 7, and A is still being worked on by processor 2, so we'll put 2 more lines underneath F to show that it's completed, and then that opens up B, and we still have B that's open, but G still has a higher priority, so that's why we assign it next. And that takes processor 2 to 18, processor 1 to 18 hours. And during that time, processor 2 is finished with task A. So then we assign the next task, which is task B, which takes it to 15 hours. And because B finishes up, D opens up. But then we have E who's still open and D that just opened up, but E has a higher priority because 7 is greater than 6. So we assign E, which takes it to 22. During that time, task G finishes up, which opens up H. We assign H because of priority. And then D will also get assigned, both of them wrapping up at 28 hours, so you have total project length of 28 hours with no idle time, which is perfect. And idle time is where you would assign it if there was no other task. For example, processor 2 finished with a task, but processor 1 was still working on it, we would assign idle time for them to catch up if there is nothing left to do. And with decreasing time algorithm, which is down here, you will not have a chart with the brackets. It'll just be the parentheses, and with that, you'll just be looking at the parentheses. So if we didn't have any of the brackets here, A has 8, B has 7, and C has 2. So A has the highest priority, so you're going to assign that one first. We assigned it to processor 1, which takes it to 8 hours. Then we go to processor 2, and which is B, who has the next highest priority, and we assign it to that. And B finishes before A, which opens up D. between C and D. D has the highest priority, so we assign D to processor 2. And after that, A finishes up, which opens up task E. C and E are still open. E has higher priority because it's 7 hours, which is greater than 2. So we assign E to processor 1, which takes processor 1 to 15 hours. And during that time, task D is finished up by processor 2. So then we go to task C because D is at the end. So we can just look at what other task is open, which is C. C finally gets assigned to processor 2, which takes it to 15 hours. So processor 1 and processor 2 are both at 15 hours. So after that, F opens up, and that is a perfect situation for idle time. So we assign task F to either one of these. It doesn't matter which processor because they're both at 15. But because F is being worked on, but we have another worker who doesn't have anything to do, we give them idle time. So it's a small I, lowercase, and you just catch up to whenever the task being worked on is finished. In this case, it'll be 5 hours, so they're both at 20. And then after F is done, G opens up, and we assign G to one of the processors and assign an idle time to another one, and we repeat the process for H until it ends at 41 hours, so your project is finished, and your total idle time is 26.
I have a question.
Yes.
Usually is decreasing time algorithm longer than critical path?
It really depends on the schedule you have and how many workers you have. So if you have 3 workers in this situation with this schedule, you will have a lot of idle time because you don't have a lot of tasks to do, but it really depends on the problem you're given.
Dude, peanut butter good element. What are you talking about?
Anyone else has any questions? No?